Okay, so the idea is to talk now about the MMU and the virtual memory. You will see this animation, it's quite impressive, done by Gemini Pro 2.5. Anyway, the idea is to talk about the memory management unit in operating system and the virtual memory, and to see how the CPU, we give him a virtual memory such that he will think that he has much memory, much more than he really has, and by that, working with the MMU to bring data from the RAM, and if the data that we need, that the CPU asks for, is not in the RAM, we will go to the secondary memory, much slower memory, the SSD. So we start by getting requests for data from the CPU. It will go to the MMU. The MMU starts by looking at the TLB cache. TLB stands for a translate leukocyte buffer. And in the cache, it is much faster. It hangs and it holds the translation from the virtual address coming from the CPU to the physical address where the data is. And if we find the data, we bring it back to the CPU. And this is if the data or the virtual address the CPU asks for is in the TLB cache. TLB cache usually holds the most frequent use data because it's very small, so it cannot hold many translation of virtual address to physical address, so it also only holds what the CPU most commonly requests, the principle of locality. And if it's not in the TLB in the cache, we'll go to the RAM. RAM, there is a page table that would translate from the virtual address to the physical address. In the physical address, again, in the RAM, we'll go to the area with the data in the RAM. There is the page table area and there is the data area. If we found it in the RAM page table, so it's in the RAM, the data that the CPU wants, we get to it by the physical address and bring it back to the CPU. This is called the TLB miss because the translation wasn't in the TLB. Now, page fault, which is the slowest, is when the CPU asks for something and it's not in the TLB cache and it's not in the page table in the RAM. We must go to the SSD, the secondary memory, which is much slower to bring it from. And in order to do so, there is a fault that it's called page fault because it's not, the translation is not in the page, the data is not in the RAM. We need to bring it from the secondary memory. It's much slower. Now let's see how each of those scenario happens, and all of this is managed by the MMU, and it's the basic of the virtual memory. Now MMU also has roles in like security of data, so that the CPU running something won't get to somewhere that it cannot or should not get to, like data in the operating system, for example, which should be read only and things like this. Now let's see the scenarios that can happen. Three scenarios: TLB hit, the translation will be here; TLB miss, it won't be here, but it will be in the page table in the RAM, and then we get for the data and get back to CPU, or it won't be here, which is a page fault, we go to the SSD. So let's start with TLB hit, the fastest. The translation will be right over here. So here the CPU tells me I need the virtual address this, I see it in the TLB cache, going to the data in the RAM and bring the data back to the CPU. This is the fastest thing that can happen because it went straight to the cache, which is very fast, to the RAM, straight to the data, not going throughout the page table in the RAM. Now, this is the first scenario, the fastest. Now, if the translation from virtual address the CPU asks and to the physical address is not in the TLB cache, it is called TLB miss, translation leukocyte buffer. I called it, I think TLB stands for translation leukocyte buffer. TLB miss is if the translation is not in the cache. So what will happen? Let's see. So again, the CPU asks for an address that is not in the TLB cache. So I need to go to the page table. There I find it and go to the data after I enter it to the TLB cache because I use it, going to the data in the RAM and then bring it back to the CPU. You saw that we went to the page table, and then we go back to the TLB cache. There we inserted to the TLB cache. So in the next time the CPU will want this translation, if it won't be replaced, it will be there in the cache and it will be much faster. So now for the last scenario, which is a page fault, namely the address, the translation for the virtual address to the physical address won't be in the RAM because the data is not in the RAM. We'll need to bring it from the SSD. So let's see. CPU asks for the cache. It's not here. Going to the RAM, to the page table is not here. It's a fault. The MMU says to the operating system it's a fault. Operating system goes to the SSD, brings the data from the SSD to the page table in the RAM and the data in the RAM. Now the TLB can get the data and bring it back to the CPU. Again, we need to bring this to here. Anyway, you saw what happened. We needed, in this case of a page fault, to bring it from the SSD, which is much, much slower. Again, a page fault. Going to the TLB, it's not here. Going to here, it's not here. Fault, going to the operating system. Operating system going to the SSD, brings the data to the RAM, and then we can bring the data. It doesn't show that it brings the address to the TLB cache, but it brings the data to the TLB cache as it should, and then it calls the data from the physical address in the RAM and then to the CPU, as we did always. So you're gonna see everything very fast. TLB hit, it's here, so we're going straight to the data, and from the physical address to data, straight to the CPU. This is TLB hit. TLB miss, the CPU asks for something that is not in the TLB cache, going to the RAM to the page table, from here getting the physical address to the translation, going to the address, to the physical address in the RAM, getting the data and bring it back to the CPU. This is a TLB miss because it wasn't the TLB cache. Now the last scenario, again, page fault, not in the TLB cache, not in the page table, there is a fault. Operating system, now it's your turn. Go to the SSD, bring me the data to the RAM, and again, update the TLB cache and get the data from the physical address we got and bring the data back to the CPU, the data that the CPU asked for. So those are the three scenarios. The main thing that the memory management unit, the MMU, and the idea of the virtual memory does, again, MMU does other things like making sure that the data we ask for, the CPU asks for, is not in prohibited areas in the memory and things like this. So protection is also important, but this was the heart, the soul of the MMU, which creates this virtual memory that the CPU thinks that he has all the memory he wants. It just tell the MMU I want this and that, and it brings it, if it's in the TLB cache, straight to the RAM, to the physical address. If it's not, going to the page table. If it's there, going from there, updating the TLB cache, going to the data in the RAM and then to the CPU. And if it's not in the page table and not in the TLB cache, page fault, operating system, bring it from the secondary memory, very slow, update the TLB cache, give me the data from the RAM to the CPU. Those are the three scenarios that are most important from the memory management unit and virtual memory to create this virtual memory in the computer. Thank you very much. Thank you, Gemini, for the animation, which is quite nice. There is a little bit of thing that needs to be corrected, but okay. Even maybe we'll put this animation down below, maybe in the description. And thank you very much. And that's it for now.